Hi everyone. Today we got a special recitation because it's recorded, so you can say hi to the camera in there. This will go to YouTube, so don't make mistakes. I'm gonna upload it to YouTube. Yeah, so today we're gonna do like, if we make those two examples that I wrote down already, if we can solve those, I think it'll be a successful recitation. That's what I wanted to learn how to do, how to solve these ones, and I bet, given like how involved they are, probably if they were to appear in a quiz, it would be about like this level of complexity. But before we go into that, I just wanted to remind you of like some of the, why this procedure works in general. So I'll write it here as motivation. So we are solving, as usual, this system in here. But now the idea, and this is just from the notes, like if you want to look at that as well. But in here, just choosing, also now decomposing A such that you can write A as P times J as P inverse, and now you let Y, like a new variable, just be equal to P times X in here. And the reason why this is kind of neat is because you can now say, all right, the system is equal to X prime times Pj P inverse X, and that is just Pj times P, hold on, I'm just looking in here, did I write it correctly? I think so. Yes. No, actually, I think I'm writing it wrong. Is it like P inverse or is it P inverse P?
It's P inverse in the back.
It's a P inverse in the back.
Yeah.
Right? Alright. Yes, because the way I was going to simplify it is that yes, you could write Y in here, but I guess I will leave it like that. And then you can multiply by P inverse on both sides, so then you get like P inverse X prime, that is just going to be equal to. Well, what is to say, like, don't worry about this because I got confused in the derivation, but this is like the most important fact that matters in here. And we'll be using that in just a second when we look at the derivation in there. And then what else did I want to say about this? I think we can just get started with like these two examples in here, and then I'll go explaining as we go. So how would you guys go about this one, if I throw you that question? Or suppose, like, forget about that. Suppose you wanna, like, it rhymes with like Jordan canonical. So why don't we try to find that, right? And see where that takes us. If you're like stuck, just find the Jordan canonical form. That will give us something. So do you guys wanna give it a shot, at least do a couple of those steps? Like finding the characteristic polynomial and the Jordan block matrix for that one. I don't think it's that hard for that example. So that's always a good step that you can use to like start this program. I realized where I was wrong in here. I just wanted to write that. No, yeah, I was just confused myself in there. But then if you then take a look at this little derivation in there, it tells you why you can either look at that system or you can look at just y prime equal to that. But we'll take a look at that one later on. So it doesn't matter now. This is like at the beginning of the notes for today's. It is true that while I was reading this, I was also trying to convince myself why all of this works. So that's why I wanted to like mention that part, but it's not that important. Any thoughts on that one? Don't be shy. Or I can get you started if you want. You know that definitely if you were to find the characteristic polynomial, right? So car poly that is just gonna be equal to 5 minus lambda squared. And that's it. Because you're just taking in the other determinant. So you know that then if you were to find now I wanna do the kernel of A minus 5i, this is going to be equal to the kernel of 0, 0, 1, 0. You know that's going to be the vector, I'm going to write it as the span of the vector 0, 1. Does that make sense? I mean, so you know that if you were to apply that vector, it's just going to have like that eigenvalue. So then the nullity of A minus 5i is equal to 1, so then that means you only have one Jordan block for lambda is equal to 5. So like so far it's like business as usual, like there's nothing too fancy, so then you can just write that J is gonna be equal to 5, 1, 0, 5. Now the challenge is finding the P matrix, so now we will, and that's why I chose like these 2 by 2s, because finding the P matrix is for the bigger ones is a little bit more involved. So for the P, since you know that already the kernel is that, then I'm gonna say, alright, I'll write it here, finding P. So in this case I'm gonna say find B such that B is not in the kernel of A minus 5i. So I'm gonna say that this V, if you guys can see there, I'm just gonna say it's simply 1, 0. As easy as that. And then step 2 is, and I'm gonna call this one like V1. And then I say let V2 be equal to A minus 5i times V1. So in this case, if I multiply this by that, I just get, well, I'll just spell it out 1 second. That's it. So then P is going to be equal to 0, 1, 1, 0.
Wait, does it matter if V2 is in the span of the kernel? Or
Oh, this one? No, that's fine. Well, at least I checked it in MATLAB before coming that this would work. So I know this example will work. I was getting scared. That's why I'm not doing the 3 by 3. For the 3 by 3 I failed while I was working it by myself. That's very unfortunate. Then you can write that in this case it's going to be equal to 1, 0. 5, 1, 0.
You know how we usually work backwards to find the vectors? Does the ordering matter if you should?
I just number them differently. in here. I'm calling like the, when I construct the B matrix,
Oh,
I put like, so this one is V2
yes.
and that one is V1, but like, yeah, I was following like the convention in the notes, but yes, that's how you would do at least this step, and we'll repeat all of that maybe a little bit quicker on question 2. So now let's do something more interesting, but let me just check my notes for that one. So now we need to bring this into like the form that is all of this stuff. So I'm gonna erase it here. I don't know what you guys can copy that stuff. There we go. So let me check in here. Now we can write it in the following way. We can say that now if we have the problem this y prime is equal to j times y, we'll solve this one initially. Then we can just say that y, the general solution for this is just going to be equal to y times c1 times e to the 5p times the first vector. In this case it would be 0, 1. No, it would be actually, I'll tell you in a moment. 1, 0, and then c2 times e to the. So the reason why I was saying that I liked it a little bit better how Ellen was explaining it, because in the notes they go straight to this form. Like they write it like this. So you have a Jordan block, say of size 2, and then you write first the vector, this actually has to be a 1. Then you write the vector 1, 0, and then you write the vector t1. It just so happens that if you continue writing all of this stuff, then you can say that this is going to be equal to the matrix, let me see, in here, how am I writing it? Well, actually, before I do that, I'll do something else. So now you're writing y, then if I want to write x, then I'm just going to let x be equal to p times y. So in this case, right, that's what I'm doing. So I'm just going to say that x is going to be c1 times e to the 5p, and then 0, 1, 1, 0, 0, and then plus c2 times e to the 5p. This ends up being c1 times e to the 5d times 0, 1. I'm mistaken, then plus c2 times e to the 5d times, this is going to be equal to 1t. Do you guys agree with that? One second, so that would be your general solution for x, which is what Ellen was mentioning downstairs. It's just multiplying this one by p, because of what we had said about how we are replacing it. But now it gets even more interesting, which is, well, not more interesting, it's just like you can simplify this a little bit more. But then you can potentially argue that this is just the matrix 0, 1, 1, 0, e to the 5d. I think if I'm not mistaken, that is correct. There. So like they make you, so in the notes they make you go through all of this procedure just to realize that that is P times the e to the jt, right? Because this is the matrix that we saw times the two coefficients. So they're equivalent, if you write it one way or the other one. I mean, have you guys read the notes already? Well, maybe you didn't, maybe you did, but that's something that I thought was cool from today. So that's, and if you see, it does work. You're multiplying that one by that, and then those two, they just flip. Any questions? What about that? Now, So we said that this is equal to x. So then x of 0, then that would make this a 1, and a 0. Right? So then x of 0 is just 0, 1, 1, 0, times C1, C2, that is equal to 2, 1. I think that makes it like also fairly easy to solve. So you can find what C1 and C2 have to be. In this case, you would know that C1 is going to be equal to 1, and C2 is going to be equal to 2. It is just like flipped. So I think it's like quite neat when you write it in that particular form, because it makes it a little bit easier to solve. Any questions about that? If not, we can work on that one. And hopefully once we're done solving that one, I think it'll be pros with this approach. I'll let you copy for a moment before I start erasing. But it's essentially we'll do the same thing. Although we might just jump, I might just avoid doing all of that stuff. I'll take the eraser. I mean, maybe we'll have time for a 3x3. It depends on how much, if we do this one quickly. Actually, any ideas for the characteristic polynomial? Over this one.
Lambda plus 1 squared.
Lambda plus 1. Yes. No, that is true. I was thinking like one. I was thinking lambda and plus 1 square. I was like, well, that is very interesting. I was trying to figure out where it was coming from. No, that is definitely true. In here. So I guess I'll just write the. So this would be plus I. Do you guys agree with that? Why it is true? The kernel is just the vector 2, 3. I'm just looking, like these two are just multiples of each other. So I'm multiplying that by 2 and that by -3, and that will give me 0. So we're gonna apply the same procedure to find P. So I'm gonna say, all right, fine. I'm gonna say, and then just another reason is that you see that this has nullity, and also one Jordan block. There's one thing that was confusing to me. There was like when you're looking at the 3×3 case that you have to take the powers. Since you already know that well, you have nullity 1 and then you have one Jordan block and then you have just like 2 eigenvalues, you can stop here. So there's no need to like continue taking powers. So yeah, so just for finding the matrix P, you can say find V1, and in this case I'm gonna set it as something that is outside of that, so I can say V1 is equal to the vector 1, 0, and then V2 be equal to A plus I times V1, and that would just give me that one. Perfect, so then P is going to be equal to V1, so that is just 6-9. That's it. So we can leave it there. And then again, because you know that it's a Jordan block that is just 2 by 2, you can apply like the same idea here. Or you can just try spelling out, or you can, well, one thing that we haven't done is finding the fundamental solution, but I'll do that in just a second. But you can write in this case, that would be -1. Oh, the same thing. I guess even x. But maybe I'll leave it there so that we can try doing something else instead. But any questions about this, or do you guys think you'll be comfortable solving like 2 by 2 systems?
Can you write out the ETJ form?
Yes, we'll write that in a second.
Okay.
I'll just erase some of this here. Now you can be asked in here question. What is the fundamental solution? And this is where you would find like you would write like this. So this is going to be equal to e to the at. But we know that A is simply going to be equal to P, J, P inverse. So this is the same as writing P times e to the JT times P inverse. And here. So if we were to do it for like that example that we just saw there, then for that would give us 6 negative 9 1 0 times. Maybe I would say that in this case J was equal to if I give you that j, what do you think e to the jt is gonna look like?
E to the negative t.
Yes. So let's write. Well, let's write it here. So yes, e to the negative t. What about there?
T e t.
No, also.
Oh, it's negative t. Okay.
And then this is what we were just doing downstairs. And we can do more examples of that if you guys want to. And then just. That's it. So this is like the other form of. Then they can ask you to do like the same, but I think that is mostly what you would need to know for at least this part.
Do we need the constants? Oh, sorry, constants in there. That one.
No, I'm just writing that. Then you can write like the journal form where you're multiplying that by C1 and C2.
Would the t in the top right be negative?
The T.
Right there.
Like that one, you mean?
Yeah.
That's
That is my confusion also.
actually, I don't know.
Where are the signs coming from?
I was just following like the convention. They have like e to the negative t, then t squared, then t cubed, and so on. And the only thing that you would change is the exponent. But I can check that. I thought when I was solving this, I just left it like that. Maybe I was being a little bit loose with the notation. Yes, other than this, we can. I can try solving like one last problem.
I think
Yeah.
it's positive t. It's not negative t.
It's positive t.
According to the Ellen's examples in class. Yeah.
Well, I'm glad then that it was fine in the end. I just like delete this. Well, let's do one last thing. And in this case, that we won't find it, so just find the Jordan blocks. But I'm assuming, hopefully, once you do that step, which in my opinion is the harder one, the remaining part of the procedure is not that terrible. I'll give you like this matrix, which will look very familiar because I didn't know Ellen was gonna do a very similar problem, so that's on me. I would say. The matrix I have written down is 2 and 2, then 0 to 0, and then 0, 0, negative 2. Which if you look in your notes, you'll see that you probably already know how to solve that example. Well, you can give it a shot just for fun, just to make sure that we know. At least we can write. I'll just add an additional question which is and then find e to the 18. That's it. That's all I'm going to ask you here. It was tricky at one point when I was working this example, finding the P matrix. I didn't remember the rule of the cyclical vectors. So I was trying in MATLAB to see whether it would work, and it was giving me like random answers that just weren't correct at all. But I can write you guys that procedure too. For one of the blocks it will be written on. Any ideas? For the characteristic, no.
Oh, characteristic. 2 is about 2 minus lambda squared times lambda. It's minus 2 minus lambda.
Yeah. I was just looking at the diagonal since it's already upper diagonal form, and let's say that the carpoli is gonna be equal to 2 minus lambda squared, and then so now it's a matter actually. If I'm just asking you for the Jordan block, not even the P matrix nor anything like that, it's a matter of looking at what the nullity of this one is going to be. If we have 2 or 1 blocks. And you can probably guess it that we'll just have 1, but we can give it one shot in here. So I'll just say, well, I'll just write this straight like here. So I'm going to plug in 2, then like 0, 1, and then 0, 0, 0, 0. And then 4. You know that this will have nullity equal to 1. And in that case,
But this nullity is actually 2 though.
No, the square will have nullity equal to 2.
But this nullity is 1. It's 2.
Is it?
Is it not? It's not. Yeah, I'm tripping.
Oh, like again, just there's only one vector that is going to be in the kernel.
Yeah.
And there.
Yeah, right.
And then what you can say is that then the Jordan block for lambda equal to 2 is just this. And then J is going to be equal to negative 2 equals 2. So hopefully that makes sense because it's from a couple of weeks ago. But now the question is, what is that in there? That's the last thing. Once you know what J is equal to.
E to the negative 2t.
Yes? Yes. And you
E to
have.
the 2t.
Mm-hmm.
T times that.
That's it. So hopefully not too bad. So I think if you can make it to this step, you'll survive the next week. That's it. I'll just cut it here, but it's already time. And